Hi everyone, welcome back to my channel. I am Dr. Shibaz here. So in this video, we will learn how to assess linearity and multicollinearity in R. Linearity means the relationship between two continuous variables can be reasonably represented by a straight line. We can assess it using scatter plots, correlation analysis, and regression residual plots. Multicollinearity occurs when two or more predictor variables are excessively correlated. Severe multicollinearity can make regression coefficients unstable and difficult to interpret. So we commonly assess multicollinearity using correlations, tolerance, and the variance inflation factor VIF. As general guidelines, VIF values below 5 and tolerance values above 0.20 indicate no serious multicollinearity in our data. Values above 10 and the tolerance values below 0.10 indicate a serious problem. So in this video, I will demonstrate how to examine scatter plots, calculate correlations, obtain VIF values and tolerance values, and interpret the complete results in R. Please like the video, subscribe to my channel, and turn on notifications for upcoming videos on R data analysis. So in this way, first we need to consult our PowerPoint presentation to see the recommendation, threshold values, and the criteria. So we are going to test linearity and multicollinearity of data in R. We are checking whether predictors relate linearity to an outcome and whether predictors overlap excessively. So we will see scatter plots, residual diagnostics, correlations, VIF, and tolerance levels. Okay, so the two assessment answer different questions. Linearity is the relationship between each predictor, mean independent variable, and the outcome, which is a dependent variable, approximately a straight line relationship. So in this way, we'll check scatter plots and residual versus fitted plots. On the other way, we will see multicollinearity are two or more predictors, mean independent variables, so highly related that their unique effects become unstable. So we will check multicollinearity using correlations and VIF values and tolerance levels. So our research context and hypothesis research question can prior knowledge according to our data. So we have a data set of 15 students. These are prior knowledge, study hours, and attendance. So these are three independent variables, mean predictor, and this one final score is our outcome, mean dependent variable. So we will check prior knowledge, study hours, and attendance as predictor variable will predict final score as outcome variable. So in this way, we develop the research question as prior knowledge, study time, and attendance predict students' final test score or not. So assessment hypothesis linearity, each predictor has an approximately linear relationship with final score. And multicollinearity predictors are not excessively redundant. Use plots and threshold together. So in this way, linearity is assessed visually and through residuals. So we will check scatter plots predictor against outcome. Add a linear trend line, residual versus fitted values, partial residual or component plus residual plots, look for curves or systematic patterns. So we will interpret the finding as acceptable pattern, points, form an approximately straight trend and residuals are randomly scattered around zero. On the other hand, if we don't find the values and points around zero, so then curved patterns suggest transformations or non-linear terms may be needed. So we see the threshold values like multicollinearity uses correlation, VIF value, and tolerance level. Common guidelines, correlation value as the recommended criteria, the R value should be less than 0.80 is often acceptable because the correlation value falls between -1 to +1. However, in some cases above 0.8 or above 0.9 consider multicollinearity. On the other hand, VIF value should be less than 5 is commonly preferred. It may be equal to 5. This is also good, but also there are some scholars who suggested that VIF value may be less than 10. So there is also another criteria. However, we'll check as per the recommended threshold value, the value of VIF should be less than 5. On the other hand, we will check the tolerance level should be greater than 0.20. So we check what multicollinearity causes: unstable regression coefficients, large standard errors, unexpected coefficient signs, difficulty identifying unique predictor effects. So model may still predict well overall. So now we will back to our RStudio where we will perform both tests. So first of all, we need to import our data in R. So I just give data to ChatGPT and request it for coding. So first we will import data in R. We'll copy this prompt and then import data in R. Okay, so we will select the data. So data has successfully imported in RStudio. So you can see the standard summary, descriptive statistics, minimum value, first quartile, median, mean, third quartile, and a maximum value. Okay, next we will create the regression model first. Copy this prompt and paste here. So in this way you can see the regression model. The minimum value is -3.2090. First quartile value, median is -0.0971, third quartile, and maximum value. On the other hand, we can see here intercept value according to estimate and prior knowledge. The estimate value means beta value is 0.80852 and the t value is less than 1.96 and the p value is higher than 0.05. So it means the prior knowledge did not predict the final score. So it means prior knowledge has no significant impact on final score. When we see study hours, so we see the unstandardized beta value estimate 2.0692 and the t value is still less than 1.96 and the p value is again higher than 0.05. So it means study hours also doesn't predict final score. On the third predictor, attendance also doesn't predict final score. So it means all three predictors did not predict the final score as outcome variable. So you can also see there is a R-square value 0.946 and adjusted R-square 0.9313. F statistics, degree of freedom, and the p-value. In this case, we can see the F statistic, our model is fit because the F value is less than 0.05. So now we will check the linearity using scatter plots. We will copy this prompt and then paste here. Okay, so you can see here in case of data for final score and prior knowledge, final score and study hours, final score and attendance. So you can see the relationship, the linearity between prior knowledge and final score is not stable. because the points are not close to 0. And we can also see here the linearity between final score and study hours. The points are closer to trend line. However, the most of the points are far away from 0. So in the same case, you can see here final score and attendance, the linearity is looking something good because the points are scattered on trend line as the previous trend line between final score and study hours. Okay, so now we check the linearity using residuals. Okay, so in this case, you can also see that the residual values are scattered above and below the trend line. This is called reference line. But the values are between -3 and +3 because the standardized residual values should be between -3 to +3. So our values are between -3 and +3. You can see here only one point is below -3. However, it considered within the -3 value. So you can also see all above points are under 3. So it means we are not violating the rule of residual values. Okay, next we will check the multicollinearity using correlations. First we check the linearity by using standardized residuals and scatter plots. Now we are going to check multicollinearity by VIF values and tolerance level. Okay, so we check that correlation matrix, there is a positive correlation between prior knowledge and study hours, and the correlation is less than 0.8. So there is also a positive correlation between attendance and prior knowledge. So it means there is no multicollinearity issue between prior knowledge and study hours and attendance. However, if we see there is a high correlation between study hours and attendance. You can see here the correlation value is 0.97 to 1402. So it means the value is higher than 0.8, even it is higher than 0.9. So there may be a multicollinearity issue between study hours and attendance. So we will check VIF value and tolerance level, then we will decide if there is a confirmed multicollinearity between study hours and attendance or not. Okay. So now we will check the multicollinearity. Okay, first of all, we need to install this package car, and we have already installed. So we move to next. We need to run the VIF test. We will copy and paste in. Okay, so we check that. You can see here the VIF value for prior knowledge is less than 5. So it means there is no multicollinearity issue in prior knowledge data. However, as we identify there is a high correlation between attendance and study hours, and you can also find the value of study hours and attendance are higher than 5. So it means there is a high multicollinearity. Okay, now we will also see the tolerance values. Okay, you can also see here that in prior knowledge the VIF value is 1.4 as less than 5 and the tolerance level is higher than 0.20. So it means there is no multicollinearity issue in prior numbers. However, there is a multicollinearity issue in study hours and attendance. Because the value of VIF are higher than 5, on the other hand, the value of tolerance are lower than 0.20. Okay, so in this way, we check the linearity and multicollinearity in our data set. So now we just copy this command to save all results and put in one Excel file. Go paste here and then press enter. So R successfully created all linearity and multicollinearity results. So you will find the file in the same directory we are working. So these are the results. So in this way, we perform linearity and multicollinearity test in R. If you find my video helpful, please subscribe to my channel and press the bell icon.